is watching this video. My name is Sir and Engineer Olenjolai. I would like to welcome you into this interesting and fantastic video, which is a sequence of engineering mathematics lecture. And I would like just to give you some few announcements which are very important, and you have to go through and you have to note them, and actually that will help you and follow what I want to tell you right now. So the first announcement that I would like to present to you, I would like to welcome all of our viewers to this lecture of engineering mathematics, and today we are going to focus on calculus, and calculus has three branches: differentiation, integrations, and differential equations. So the concept that we are going to cover today is integration, and actually it's a critical disease for undergraduate students. However, that I'm going to teach the fundamental, and the main focus of this lecture is targeted for ordinary diploma students who are doing engineering, and also others who are doing science, such as lab tech science and every kinds of the science. These materials, they're going to help them everywhere in the world, because the way that the engineering and the science that we are studying worldwide is similar. Okay, different way of teaching, way of experimenting it, and way of applying. So that's the first announcement. The second announcement is, when you start watching these videos, please look at your right side of your video, and then you'll see the buttons of subscribe. Please press that buttons and then go right side. On right side you'll see a bell. Click that and then select all. Why should you subscribe? There are many advantages for you to subscribe, but one of the very important advantages, YouTube community will notify you wherever that I add a video onto the channel. The name of the channel is Olenjolai. That's the name of the channel. Let me just write it for you. So the name of the channel, in case that you want to share, the name of the channel is called Olenjolai. You can just write in uppercase or in lower case. So this is the name of the channel that you're watching right now. So when you subscribe, whenever that I upload, because I'll be adding several videos concerning about or discussing about teaching about integration. So whenever that I subscribe, whether during the night or during the day, and you are online, or maybe you are offline by that time, but later on, so if you get into the online, YouTube community will notify you that I have uploaded a video, so you can join the class wirelessly. So that's the second announcement. The third announcement, actually, when you subscribe, also is you have an options to like or to dislike, and even you have an options to share with your colleagues wherever, in any engineering university, who are doing diploma studies, and even those who are doing undergraduate studies, whether the first year or second year, because in engineering mathematics for undergraduates, most of the concepts need applications of the fundamental concept, which actually they should have already covered in A-level studies for those who have gone for advanced, or in ordinary level studies. So these materials can help even undergraduate students who want to review the materials at which they have been taught before going for further studies of undergraduate studies. Okay, so that's the third announcement. The fourth announcement, actually my class is incomplete without questions. So use the comment sections below of the video that you're watching right now to ask questions, and put any kinds of the comments. It means let us talk. Let I and you talk there by using writings, because there's no any video that actually can record for me. Okay, so that's very important. Make sure that whether you didn't understand, the comment sections give us interactions. Ask the point that you didn't understand along this video. Ask any kinds of the questions. I will give you some homeworks, even if that, I think that is good if you do that homework. And then after you've done it, you can put in the comment sections. I can go through and see that whether you're right or you're not right. So the class will become very interesting. One thing which I would like just to promise you, in this channel of Olenjolai, actually that you will enjoy mathematics. If you hate mathematics because of the bad teachers, bad foundations that you had, bad fundamental ideas, or actually that maybe slightly or shallow materials that you have been learning along the way, I believe that just give me opportunity, because I will make you love engineering mathematics. That's the main visions and the main mission that I have in this video. So don't be discouraged. engineering mathematics is beautiful and is simple, even more than you've seen. Okay, and then the last announcement, which is number 5, I would like just to dedicate this video, as I've already just said, to all ordinary diploma students and undergraduate students who want to review their ordinary concepts of calculus. Okay, so I dedicate, and especially I dedicate to my ordinary diploma students who are studying at Dar es Salaam Institute of Technology. I used to teach them electrical engineering modules. I dedicate for them. I think that they'll enjoy it because it will be the second semester module. So now let us go to the business. Join me. I would like to welcome you. Now we have the very important information, how to go through them. So the subject is called engineering mathematics. And in today I want just to teach you something which is actually very exceptional and very special for you. In engineering mathematics, before we go to the name of the modules, which is called integration, okay? Today we have to start with hierarchy, okay? This we call it hierarchy. Hierarchy of engineering. Hierarchy of engineering mathematics. Hierarchy of engineering mathematics. And again, you can just write, today I want to start with a big picture. Okay? So, big picture. So just write it, big picture. What does it mean about the big picture? The integrations, it didn't just come from somewhere else. It means just it come, integrations actually has some top layers where it come from. And actually, if you want to understand, you have to know the fundamental. It means where does it come from, so what should you cover before you go through for integration. So in this hierarchical of engineering, I just want to start from this point. We have the subject here, which is a fundamental subject in all the fields, which we call it mathematics. And this mathematics, according to the many literature review, we call it the queen of engineering. Say it, queen of engineering. Okay? So under this perspective of mathematics, we can classify mathematics into main branches. Okay? Here we have pure mathematics, and actually we did this pure mathematics during the A level for those who have gone for A level, just like introduction of the pure mathematics. But you can do bachelor of science in mathematics for undergraduate, and also for postgraduate. And here we have another important branch which is called applied mathematics. So applied mathematics, it means that in this concepts of applied, or in this branch of applied mathematics, means that we are going to take many concepts from pure mathematics and just apply to solve real world problems. And as this apply, okay, so our main focus, and my main focus is not on the pure mathematics. My main focus, under this perspective, also we can have different classes or different areas where you can apply mathematics. Okay? So we have engineering, which is our point of target. We have engineering, and we have different types of engineering. We can also apply mathematics in economics. So we have economics engineering. We can also apply mathematics in medical field. Okay? We can also in medical field. Can also apply mathematics in software, right? Software, etc. So we have different areas where we can apply. In business, we can also apply mathematics and so forth. So our target is engineering mathematics, and right now, that's why that we say that the name of the subject is engineering mathematics. Okay? So that is. So now, if just I go through this engineering mathematics, if I take now the branch of engineering mathematics, let's say, we have different topics, okay? Different topics which actually combine together and formulate engineering mathematics. And I want you to be aware of those different topics which are very important, and then we'll see the integrations, where does it come from. Okay, the first one we call it geometry. Okay, so geometry is the one of the topic, very important topic in engineering mathematics, which study about the S, because geo means S, metry means measurement. Also, we have linear algebra. Linear algebra, this is very important also subject, because if you find, for example, in some of the cases that you find that the Fourier series, sometimes is simplify the complex series and make it very simple, just make it a linear algebra, just you solve the simultaneous equations of the three unknowns, whatever. So it can, for example, the Laplace transform, one of the methods which can actually use it to solve the second order differential equation, and actually the way that it's going to solve, you will have the linear algebra equations which actually have to solve them, okay, properly. And then another branch which is very also important, we call it probability and statistic. So probability and statistic, this in most of the universities or colleges have been taught for the second year undergraduate students. Another branch here we have analytical mathematics. Just you can call it, as I used to call it, analytical mathematics, but let just me say that, let me just enclose it. We have calculus, and against we have another terms which call it complex analysis. Okay, this is another topic. Okay, next thing after that we have against trigonometry. Trigonometry. Okay, trigonometry. So those are the sum of the topics that actually you can find, or you have to cover them if you want to apply mathematics in engineering. Okay, so remember, engineering is the broad subject again, but the good news, this is the calculus now, which is part of analytical. When you take the study of calculus now, we can have three important branches or important topics, which when you combine them together and you understand them, now you can say that I understand and I know what is calculus by the way. So here we have differentiation, and it's sometimes called derivative. And also here we have another topic which we call the integration. And finally also we have another topic which we call the differential equation. Okay. So here we have our module name today, or our subjects, or our topic which is called integration. But remember, we have integration in applied mathematics, and also we have integrations in pure mathematics. Our main focus is integrations in applied mathematics. Don't forget that. Okay? So we'll discuss later about what is integration. So just I'll give you the good foundation, but this is what you have to remember. So this is the point that we have the concepts of integration. Okay, so remember that this is still an introduction. Okay, still an introduction. So we say that now we have our name. So we say that because we say that engineering mathematics. So we say that engineering. Or we say that just we say the integration. So we say that the topic is called the integration. So integration in engineering mathematics. Okay. So let us see the contents. What are you going to cover? Okay. What are you going to cover? We'll be studying this topic, and some of the investigators will consider it as the module. The first concept you are going to cover is introduction. Introduction of integration. Introductions of integration. And the second concept that we are going to cover is integration of polynomial functions. Integrations of polynomial function. The third concept that we have to cover is integration of exponential functions. Exponential function. The first concept that we have to cover, we are going to learn about integration trigonometrical function, and they are inverse trigonometric function. Next, which is number 5, we are going to cover about integration. I will introduce it. I won't go into too much detail of hyperbolic function. Integrations of hyperbolic function. So here we learn how to integrate sinh, cons, tanh, cosec. Okay, so this we call all of them hyperbolic function. The 6 concepts that we are going to cover in these integrations are one of the branch of engineering mathematics. Also, we are going to, this is not introduction, I'm sorry, this is integration of so this is integration of integrations of rational function. Integrations of rational function. Integrations of rational function. And then the 7th concept is integration of, okay, so you say that integration of logarithmic function. Okay, so number 7 we say the integrations of logarithmic function, which we discussed. And then number 8, we are going to cover integration of this, that we are going to cover about integration of integration by using means integrating, or integrations by using integration by parts. Integration by parts. This is a very famous concept for undergraduate studies. So if you are planning to do undergraduate studies, make sure that you don't forget this concept. Integration by parts. Make sure that everything that I'm going to teach you, I would like just to tell you, I would like to promise you, because I've gone through the A-level or advanced mathematics for A-level, and also I've gone through all the calculus for undergraduate studies. So what I'm telling you, I know what you are going to face it and what you are going to face in your future. So that's why I tell you that you have to pay your attention, please. And then the 9th concept now, or the 9th subtopic which you are going to cover, is called the applications of integration. We have many applications of integration, okay? But some of them that we are going to cover here, we are going to use integration to find area of the curve. Area of the curve, okay? This is the one. And also we are going to use it to find volume of solid revolution. Volume of solid revolution. Okay? If just we have spare times, we can also find length of arc. Okay? And then if you have enough times, also you can find area of the sector. So these are the concepts, but the very important and fundamental applications of the integrations are two: area of the curve and volumes of the solid revolution. Okay, so I think that you have seen the overview. Where are we going, or where are we heading to? So those are the few concepts that I wanted to share with you. Okay, so we have seen. Let us start the first subtopic, which we call introduction. Introduction of integration. Introduction say introduction of integration. You can just keep on saying in engineering mathematics. Okay, so to limit yourself or to bound yourself. So in case whenever you want to introduce about something, okay, those are the principle of teaching, principle of learning. When you want to introduce about something, for example, actually it means that you should know the language of it. For example, if I want to talk with computers, I have to know the language of the computers. If I want to talk with mobile phone, I have to know the language of the mobile phone. If I want to talk with an elephant, I have to know the language of an elephant so we can communicate. So you can understand that when the elephant mentions about this terminology, I have to understand. And when I mention a particular terminology, also even the elephant has to understand what I've said. So in this part of introductions, I want to introduce to you common, famous, and very important terminologies in integration that will come across them wherever you go. Remember that these materials also can help a Form 5 student, and also it can help Form 5 students who is studying pure mathematics, and also these materials can help a Form 5 or Form 6 student or A-level student who is studying pure or basic applied mathematics, which is actually called in short basic applied mathematics, or we call it BAM. So these materials can help. So in case that you have a friend who is doing those studies, you can invite him or you can share with him all of this information. So now we are going to discuss, I'm going to teach you about terminologies of integration. Terminologies of integration. So we have a number of terminologies that I've just come across. I've prepared almost about 5 to 6 terminologies for you, which actually I think that they will introduce to you. The first terminology which we have to discuss, first of all, we have to understand what the meanings of the word calculus. Say calculus. What does it mean? You heard this word several times. But how can we define? What does it mean to say that calculus? What do you get in your mind when somebody says that I'm studying calculus or I'm solving problems of calculus or I want to apply calculus in engineering? Okay? So the first question that we want is ask yourself, what is calculus? What is calculus? So I found one of the definitions. There are different resources which actually can define or have been defining this phenomena. So I found one of the definitions which I want to share with you. Calculus is a branch of mathematics, as I have already explained to you in hierarchy of the engineering mathematics, that deals with defining and the properties of derivatives. Properties of derivatives and integrals. And integrals of functions. Functions by methods. Originally based on summation of infinitesimal differences. So calculus is a branch, keyword, is a branch of mathematics that deals with the finding and the properties of derivatives and the integrals of the function by method originally based on the summation of infinitesimal differences. What it means of the word infinitesimal differences? It means that by using calculus, we can take a large structure, for example, or let's say I want to calculate the area of this class, right? So by using calculus, what I just want to get, I want to get the area of the slice, let's say of the slice, very small slice. For example, I want to calculate the area of all of this blackboard. Let me just do a demonstration for you. I've been given, Olenjolai, I've been given an assignment to find the area of this rectangular blackboard. So how can I find the area? Actually, I have to take a ruler and measure the length of this blackboard. And also, I have to measure the width, okay, or the height. This is the height of the blackboard. Okay, so if I get now the length and the width, but again, this is actually it is three-dimensional. It's not two-dimensional. I mean that there is a thickness also. I have to know the thickness from this point to another point. So I can find the area of this figure. But by using integration now, instead of dealing with all of this blackboard, I can just take a small section which is called infinitesimal. I mean that, what does it mean? I can just cut this blackboard from here, let's say, from this point, in a straight line. I can just cut it, a very small section, just like the line I drew it from the top to the bottom, up this point, and then I just find the area. So this is the area, so this we call it a slice or infinitesimal. So this is an example for infinitesimal. Infinitesimal. Okay? So if I know the area, for example, if I know just the formula of the area, let's say, of the blackboard is equal to a certain function, let's say f of x. Okay? This is the area of a small slice of the blackboard. Now, I have to know what the length from this side to this side. And if I know now, I will integrate from A to B. This is the lower limit. A might be 0. Let's say that up this point might be 12. So I'll be integrating the whole functions that now the whole area from 0 to 12. That's the meanings of infinitesimal differences. So this is if I want to find the area. But also we have differentiations, because outside the derivatives and the integrals. Because you say in calculus we have 3 branches. Differential questions, the combinations of derivatives and the integrals. So the main and the fundamental concepts are derivatives and not the integrals. Differential is just the combinations of both. So that the meanings of this branch of mathematics deals with finding derivatives, finding integrals of the functions. Also properties of derivatives, and also integrals means properties of derivatives, and also properties of integrals of the function by the method originally based on the summations of infinitesimal. So integrations also is called or is defined as a reverse process of differentiation. Also integration we can define just like a summation, so it's a sum. So especially for Riemann, who was the mathematician who introduced this idea, because there are 3 mathematicians who introduced this idea: Riemann, Leibniz, and Sir Isaac Newton. So all of them, especially Riemann integrals, actually is relating the integration signs with summation sign. Is it interesting? Yeah. So another simple definition of integral, we can say that integration of calculus, okay, that's just about dot integration, the reverse process of differentiation, okay, good. So that's the first terminology, okay. So this is in case of of integral. But in case of derivatives also we can find, that if you want to find we say that the length of the small segment, or if you want to find maybe the Taylor series, or you want to find the Maclaurin series, so you'll find that you need to find the infinitesimals. differences in those cases. Okay, we want to find the area of the small area, we want to find maybe the length of the tangent, normal, and the, we sort of call it point of tangents, and also, that is. So that's the first terminology. I believe that there's a lot of information you can just extract, you can add up there, but I've given you the fundamental here. The second terminology, which is very important for you to know, is called integration. Remember that this topic actually deals with calculation, a lot of calculations which we are going actually to discuss. So we have a number of calculations. This is just like an introduction where we have kinds of very important instructions. So in lecture 2, no any writings, no any sentence like this. Just like put the question, solve, we integrate, we are done, and you'll enjoy it. Integration. So what is integration? What is integration? What is integration? So I found one of the definition, actually, which is the basic. We say integration is a process of finding, simplest definition, finding integral or integrals of the function. This is the definition of integration. Integration is a process. Integration is a process of finding integral or integrals of the function. So this is a process. It's not just like a simple, or just like you just integrated and that. It's a process, remember. So you say a process means that there's first step, second step, sometimes even up to 5 steps. Okay? It's a process of what? Finding integrals, or in plural we call it integrals, of what? Of functions. It can be single variable functions or it can be multivariable functions. Depends to the level that you want to learn about integration. In some of the engineering curriculums, they used to call it integration 1, integration 2, and integration 3, depending on the level of the studies. Okay? So that's the definition of integration. Hopefully you have understood. So it's a process. We have integration, we have integral. So differentiate them. The third terminology is called the integral. And this word integral I've already introduced it here. So this is the third terminology. So if you want to understand integration, you have to know the meanings of integral. Because you'll hear in the lecture, in the physical lecture, or in the online lecture, or in different books that you are going to read of integrations of calculus. So the question we have to ask ourselves, what is integral? What is integral? Okay, what is integral? What do you understand when somebody says that this is the integral? Okay, I came up with one of definition which is very interesting. We say that in mathematics or in math, integration assigns numbers to functions in a way that can describe displacement or area or volume, okay, or and other concepts. And other concepts, okay, that arise by combining infinitesimal data. This is one of the definitions of the interval. In mathematics, integrations, which is the process of finding intervals, and now we want to understand what the meaning of intervals. Okay, so he said that assigns numbers to the functions in a way that can describe displacement, area, volume, and other concepts. What does it mean? We say that if you want to find displacement of the certain geometrical figure, then we can apply the concepts of intervals. When you want to find area of the particular figure or particular structure or particular geometry, you can apply the integration, or volume, as just I've mentioned there in the list of applications, or other concept that you want that arise. But what the concept of the integrals employs combining infinitesimal data, which I've already taught you in the definitions of the calculus, what the means of infinitesimal differences. So infinitesimal differences and infinitesimal data. So that is the same story. So we are combining. Here just I use the word combining, and in these definitions we use the word summation. They still have the same meaning. So this is the definitions of the word interval. I will give you the symbols, don't worry. I'll give you the symbols of the interval. So it means that because I didn't introduce even to you the symbol of the interval, I'm not actually, I think that just I will keep, so this is not the end of the concept of the intervals, but I will give you more concepts as I proceed with this lecture. The first terminology, we call it integrand, or we call it integration symbol or sign. What is, so we have a question here. What is integration symbol? What do you understand? What is integration symbol or sign? What is it? So integration symbol, we say that is a symbol or sign with a mathematical symbol or sign. Okay? The mathematical symbol or sign that represents integration. So remember, integration, this is the way. So if I want to represent integration now, I have to use the integral or the integration symbol. Or sometimes we call it integral symbol. So actually, this is the symbol or sign that used to represent integration symbol. So how does this sign look like? It depends to the scenario. So let me give you examples. Bring close to the subject examples of 40 of integration symbol. So examples of integration symbols. So the first example of integration symbol is this one. The second example of integration symbol, we can just write like this. This we call it double interval. The second example of integration symbol, we can just have triple interval for the three variables. Okay? Again, the third example for integration symbol, I can just write like this one, from A to B. The fifth example of integration symbol, I can have two letters, A to B, C to D. I'm not interested in integrand or what is inside, but I'm just teaching about the symbols. The six examples of integration symbol, I can have this A to B, C to D, E to F. I've never seen, maybe in pure mathematics, maybe the four integration symbols together. These are the meaning in engineering mathematics, even this one, even this symbol, especially this and this are always found in engineering mathematics. So all of these are, we call them integration symbols. So instead of writing, for example, instead of saying that integrate, maybe integrate these functions, integrate maybe f of x, maybe integrate x squared plus 4. If you write this symbol, and you write just the function which is integrand, and the variable of integration, then you're done. So everybody in the world will understand that you have to integrate because this is a symbol for integration. Similarly to this, for the two variables, means that in multivariable calculus, for the two variables, for the three variables. Similarly to this we call a indefinite intervals symbol. Indefinite, so this all of this. So this one and this, we call them indefinite interval symbols. Integration symbols, and all of these three, we call them definite integration symbol. Definite integration symbol. So I believe any questions about integration symbol? I believe you've understood. So let us proceed. That is the first terminology. The fifth terminology that you'll hear it several times, we call it integrand. Say integrand. Say integrand. Say integrand. Say integrand. So that is, we call it integrand. It's not integration, it is integrand. So always, fundamentally, we have to ask ourselves, what does it mean whenever we hear somebody mentioning about integrand? As a lecturer is mentioning about integrand, or the book is you're reading along, so you find the vocabulary called as integrals. What do you get in your mind? What do you understand? What is integrand? So you say that integrand is the function, which in integration just we call it derivative. Is a function. Okay, this is the function that is we say that this is the function that is required to be integrated. Okay, that is functions required to be integrated. This is the definitions of the integrand. So what is integrand? Integrand is a function or functions if the multiple function that is required. That is required to be integrated. So if this is the integration symbol, I have to put a function which now we have to integrate. So an integrand is a function which is required to be integrated. Or sometimes an integrand, we say that this is the derivative of a certain function. Not that. So not before. Okay? The integrand The integrand is also known as derivative of the certain function. So derivative of the certain function. Okay, so that's the meaning of integrand. So how do we place an integrand? Because in this function means the function might be generic or defined functions. Okay, so the way that now there's what are examples? Let's say examples of integrand. Let you understand examples of integrand. Okay, so the first example, for example, if you want to learn about indefinite integrand, so we say that we have integral, and then here we have generic function. So this one, this is we call it integrand, and this we call it integration symbol. Integration symbol. This is for the single variable calculus. If you have multivariable calculus, whereby we have two symbols like this, now our function should depend, because here dependent variable is y, independent variable is x. Here dependent variable should be another letter such as z or u or v, and then independent variable should be 2, x, y. Also, I don't want just to put the x in the table because I haven't taught you. So this is we call it integration symbol. Integration symbol. Okay, or symbols. And then this function is called your integrand. I will give you example. Now I'm using generic function. So this we call it generic function. So in mathematics we call it generic function. So this is the generic function. So that is in case of indefinite integrand. Okay. For triple integrals also you may do the same. So here you have f, let's say of x, y, z. Okay, but yeah, that is because you will find in your undergraduate studies. Then for finite or definite, for definite integrand. Definite integrands also we can just express the way that we've expressed there from a to b. Here you can have another, let's say, g of x, and then so you know that this is the integrand, and this is integration symbol. Want to just to be familiar, integration symbol. Okay, because I found many students they used to claim, and then for this, okay, again we have our limits from a to b, and then from c to d. Okay, so we have two variables, f of x, y, just like this. So similarly, this is integrand, and also this is a symbol or integration symbol. So from these examples and these notations, now I believe that you are coming closer to the integrations, and even you enjoy it, because before I just started with those long sentences with definitions of technologies. But now we are talking the same language, the language that you're interested in, which is Indian mathematics. Very beautiful language. Again, we have the sixth terminology, and this is called the variable of integration or differentiable of variable x. So the sixth terminology, which might be the last for today, I will give you some of them if there are. We call it variable of integration. Variable of integration. Variable of integration. Or in some of the books, we call it differential of variable x. Differential. Call it differential. Differential variable. So it means that we can speak about variable of integrations or differential variable. Those are the two names, either of the names that you can use when you want to speak about something. So what is it? What is it? So what is variable of integration? Variable of integration. So variable of integration, we say that is the variable in which the integrand, first of all, it should be next to the integrand. The integrand is the variable next to the integrand in which the integrand has to be integrated, with respect to it. With respect to it. This is the simple definition. So, what is variable of integration? Is the variable in which the integrand of the integral has to be integrated with respect to it. So this is the variable. It can be a variable or variables, more than one variables. They may give you examples. Maybe the sentence is a little bit tough for you. Okay? Because some of the mathematicians, they don't like a lot of words. They like symbols and the numbers. And actually I tell you that from the lecture 2 onwards, we'll be discussing and actually be using symbols and numbers. And the subject is very interesting. Don't miss it, please. Okay? So let's see examples of variables. Example of variables of integrations or differential variables. Integration. So now let us start with indefinite. I will tell you what the meanings of indefinite interval, because I know that I haven't told you. This is another terminology again. Definite intervals. So in definite intervals, we have this is integration symbol. You do remember. Also here we have generic function which we call integrand. So now if you have f of x, it means that this function is the derivative of the certain function, certain unknown function which you have to find. That means of integration. That's why integration is a reverse process of differentiation. So then we say that if you integrate this is respective, we have to say dx. So what does it mean? Let us do analysis. This is we call it integration symbol. Integration symbol. And then this we call it integrand. And then this one we call it variable of integration. Variable of integration. This is for the single variable. Okay? For multivariable, for example, two variable calculus means we have two variables. We say that here we have f of x, 1. And then we have two variables. We have to differentiate with respect to x and with respect to y. Okay? So the x, the y. We have ordinary and also we have partial. So in this case, remember that this is the symbol of integration. This is what? integrand, and this is what? Variable of integration. Variable of integration. The word functions is called the integrand or integral. Remember that. So not before. Integral maybe, let's say maybe the word integral functions, it means f of x dx. Integral, it means it may be, we say that integration symbol, integrand, variable fault of integration, or the integral may be only the integration symbol. So remember, it might be this or this itself. Okay? Okay, so that is in case of indefinite intervals. Okay, let us look variable of integrations if we have finite interval. Okay, finite interval. So we are going to have that integral from a to b. This is lower limits, upper limits. I will teach you about the limits. And then we have f of x dx. What does it mean? As I told you, this is integration symbol. Forget about what does a and b means. Integration symbol. Then this is what? Integrand. This is what? Variable of 40. Variable of. So this is the example one, variable of 40 of integration or differential variable. Right? And remember that the whole functions now is called the integral. Okay? So the whole function, we just connected, enlarge your concept. The whole function now is called the integral. Okay? Good. So for multivariable, remember that in this mode we are going to start on a single variable calculus, single variable integrals. In also later on, especially that for undergraduate studies, you will find multivariable calculus, multivariable integrals, double integral and triple integral, especially for the first year undergraduate studies. Okay? So for the multivariable, so that's why I'm introducing to you. So I want to tell you that what I'm teaching you, this is the foundation. Later on, so you want to advance it. So we have double integral from a to b, c to d. Here we have f of x, y, dx, dy. So what is it? So this we call the integration symbol of multivariable, integration symbol. And then this we call the integrand. And then this we call the variable of integration. Variable of integration. So if it is triple, similar story. So A to B, this is homework for you. It means analyze it, A to B. Then you have C to D. Then you have G to F. And then you have F, X, y, z, here we have dx, dy, dz. So your homework, show me where the integral symbol, integration symbol, show me where is integrand, and show me where the variable of integrations, variables of integration. This is the variables, plural, variables of integration, and show me where the integrand. I believe you'll do it. Okay, so we have already covered the 6 technologies of integration. We still have four terminologies, but those four terminologies have been attached in the types of integration and also classifications of classes, two classes of integration. So now I can just introduce to you about types of integrals. Types of integrals function. Okay? Types of integral function. Or types of integration. So we say that in mathematics there are two types of integration, which are the first one, we call it the finite integral or finite integration, and the second one we call it indefinite finite integral. So this one sometimes we call it finite in some of the books, and this we call it also infinite. So indefinite, and then it's infinite, finite, infinite, that is. So now we can have the seventh terminology from those two types, which is finite integral. Finite integrals. We still have the fundamental question: what is indefinite integral? What do you understand when you hear about indefinite integral? What is it? So it's an indefinite integral finite integral. We say that is a type of integral which is not bounded by finite values. Finite values. Notation. How can you know that this is the finite notations of indefinite integral? How can you know that this is the finite integral? Here's the way that it does not have limits. So in bracket, just write that no limits. You don't know what the means of limits, but if I will teach you the second time, so you know the means of the limit. So for the single variable, this is the notation that integral of f of x dx. Or for the multivariable, for the double variable, it's just integral of f of x y dx dy. That's the way that's the symbol. No limits, no numbers, no letters. Okay, because you can have numbers or you can have letters. That's what we call it in infinite integrals. Okay? So, this class of infinite integrals, okay? In this part of infinite integrals, we say that the solution of indefinite integral must consist the variable known as integration constant. Say it. Integration constant. Say it. Integration constant. said integration constant. In some of the books, we use C. In some of the books, you can use K. You can use any letter to represent it. Mostly use C, just like integration constant. So integration constant, we use C or K. What does it mean? For example, that if I want to solve, let's say that I want to integrate the derivative of a certain function, which is f of x dash, like this. When I get the original function, the previous function, as f of x, I have to add integration constant C. Okay? And this is very important, especially for pure mathematics, also very important. For engineering mathematics, in most cases, you find that you use the finite integrals, where we have the lower limits and the upper limit. So what is this? This is the function. So remember that. Remember our classification. This is what? Integration symbol. This is what? Integrand or derivative of a certain function. This is what? Variable of integration. This is equal sign. What is this? This is original function. Original function which has been differentiated to get this derivative. So this function, it has been differentiated. Okay? It has been differentiated. I use the concepts of what? Of the differentiation. So integration now, we do the reverse to get this. So I mean that this is what we call the integration process. That's why I told you integration is the reverse process of differentiation. And I will prove it to you. I will take a simple example, differentiate, and then we integrate. I'll take a simple function, we'll differentiate. After we differentiate, we get the integrand. We'll integrate that integrand, and then we get the original function. Very interesting. And that is similar story, regardless of the complex of the integrand, whether it is logarithmic, exponential, trigonometrical, the same story. It's just to remember that integration is the reverse process of what? Of integration. Good. So this is what? This we call it integration constant. Integration constant. I'll also teach you later what they mean. But I want just to let you know what the means of this integration constant. For example, if I have the function y is equal to x plus 2, just the simple one, right? So this is the original function. If I differentiate again dy dx, this is equal to 1. If I integrate this function that I have dy is equal to dx, if I integrate it, I will get y on this side, and this side I will get only x. Where? Because remember that if I differentiate x in respect to x, I will get 1. If I differentiate it 2 with respect to x, I will get 0. So if the function contains a constant number, right? A constant number with a variable of x power 0. If you differentiate, that constant number disappears. Like in this case, if you differentiate x plus 2, we get 1 plus 0. So the constant, the number 2 has already disappeared. This one, we can use this one, we can put in the part of the integrand, we can integrate it and we can get x. So you see that here I've integrated it, I go to y, I've integrated x, I go to x. So this 2 has disappeared. So because 2 has disappeared, I cannot guess that maybe the original function had 2, right? It might be maybe the original function had, let's say, half. Okay? The original function might be maybe x is equal to, let's say, 223. So there are many values or many possibilities of the constants which have been disappeared. And always you have to include because we don't know. We are not sure that whether the original function had a constant or not. And remember also C it might be 0. If the constant was not there, it means C is equal to 0. So C actually may be from negative infinity to positive infinity through 0. So that's why that we say that when we integrate this without any boundaries, it means without any values, we add the integrating constant. This is the reasons why. However, that I will teach you the vivid examples and actually understand that if you be writing the integration constant, you will be writing with actually with sorrow. You'll be writing with rejoice because you understand what you're writing. Okay? I still have only 3 technologies to end up this lecture. So don't get tired. Still enjoy it. I believe that at the end of this lecture, up to this moment, actually that your thought, your idea about integrations now have been advanced it to a certain level. It's not like when you didn't watch this video. So we are going for the second type, which is this. We can call it the terminology number 8. We have definite intervals. Remember that you can call it definite intervals or definite integration, the process of finding definite intervals, or we call it definite intervals. Okay? So let me just write properly. Maybe we don't see the letters properly. Definite, or we call it definite in some of the books, finite intervals or integration. You know the meanings of integral, you know the meanings of what of integration. So our fundamental question, what is it? What is definite what is definite interval? Finite interval or intervals are the intervals which are bounded or bounded by finite values in order to obtain a specific value of integration. If those boundaries are if those boundaries are, we call them here, if those boundaries are numbers, if they are letters, you can get we say that the original functions in order to obtain specific. In the finance, you cannot get the specific values of the function. Okay? So it's very important. Number 9, the 9th terminology. Before I give you the way it looks like, I want to teach you about limits of integration. This is another terminology. Limits of what? Of integration. So the question, the fundamental question is, what are the limits? What are the limits of integration? What are the limits of integration? Okay? So are the values which used it to bound the interval of the function, the certain function. In integration, you have two types of limits. Okay? Certain function. So in integrations, you have two types of limits. We have lower limit, and also you have upper limit. Okay? So you have upper limit and lower limit. So you have two types of limits. So mathematical representation means representation of definite interval. So if you just relate this one, understand. So how do you represent? For the single variable, we will represent our integration symbol with lower. So this now we call it lower limit, and then this is upper limit, and here we have our integrand, which is f of x, you have variable 40 of integration. So that's why I have been mentioning that suppose our lower limit is a, and suppose our upper limit is b, and then our integrand is f of x dx. Right? That is. Okay? For similar case also, that's why I say that for multivariable from a to b, c to d. So suppose the lower limits and upper limits of the first variable, let's say x, and c and d are the lower limits and upper limits of the second variable, which is y. That's why I say that this is f of x comma y, dx, dy. That's the reason. Okay, so remember that. Downstairs here we put the lower limits, here we put the upper limit. Don't forget about the limits. Okay? So that's the concept. So now, we go again, so we want to discuss about what will be the value now. What will be the value? So we say that the value of integration, for this case, integration does not contain integration constant. So in this case, we don't have any integration constant because the value is specific. So how will we write the value? So we say that suppose we have integral existence from a to b, and then we have f of x dx. This will be equal to, okay? So we say that will be equal to, so after we integrate, we get that this will be equal to f of upper limits, the value of the upper limits, minus the value of the function of the lower limit, like this. So no n additional of 40 of integrating constant. So that's all about 30. So remember this formula. We'll need it in applications of integrals and even for the rest of your life in engineering mathematics. So let us wind up our lecture with 3 classifications of calculus, because this is very important. We said in part of introduction, so we have that classification. Classification of calculus based on, because I know, I guess maybe you don't know or you don't have a background of this one, based on their variables. So there are 2 classes. There are 2 classes of calculus based on their variables. Which are, first one, we call it single variable calculus, because in calculus we have differentiation or derivative, we have integration, we have differential quotient. And also the second class, we have multivariable calculus. What does it mean? So here we have 3 kinds. We have 3, it means we have for differentiation, we have for integration, we have for differential. But I want just to remember that I told you in the beginning, I will make sure that you like engineering mathematics. And also here we have 3 types. We have for differentiation, multivariable derivative. We have also multivariable integrals, and also we have multivariable differential quotients, which is partial differential quotient. So let me keep on explaining in short with this by using symbols. Okay, today I will be using symbols, but I will show you on this topic of integration. So now we have It means, as I say that in calculus, if you do remember remember our hierarchical order, we say here we do have differentiation, and then here we do have integration, and here we do have differential equation. So this in abbreviations we call it DE. So in differentiation, we do have single variable, derivative, and also we do have multivariable, derivative. Similarly, in integration also, we do have single variable, which we are going to focus, single variable integrals, and also we do have, so this just we call it our hierarchy. Okay? And also here we do have single or multivariable calculus. Okay? In differential equation also we do have two of them. Single variable, here we call it ordinary differential equation, which is fundamental for A-level student and also for ordinary diploma student. So here also you have partial differential equation. This is for undergraduate studies. So here are the truths. This is a great subject or great topic which is called calculus. There are three branches: differentiation, integration, differential equation. In differentiation, if you want to classify differentiation based on the variables, you have single variable derivative and multivariable derivative. Or we call it single variable differentiation, multivariable differentiation, or multivariable differential. Okay? This is differential. That is differential equation, differentiating. Also, two classes of integration. You have single variable integrals or single variable integration, which we are going to discuss in this module. And also you have multivariable integrals, not calculus. Multivariable integrals. Okay? Multivariable integrals. Here we have ordinary differential equation, which is single variable. So this is single variable. And for multivariable for differential equation, you have partial differential equation. Here you have ordinary differential equation for single variable, and then for multivariable you have partial differential equation. I believe you got it. So let us wind up our lecture by just explaining to you on the focus of this integration. So he said that this is number, that's what number 8, this is number 9 now. Number 8, 9, 10. This is it? Number 10. So number 10, what is single? So we have what is single variable integral. What is single variable integral? Okay? Or integrals. So the question is that what are single variable integrals? So simply say that are the integrals which integrate functions or integrants with respect to to only one variable of integration. So it means that here we have only original function had one dependent variable and one independent variable. What the notation? How can you know this? Because the whole modules and the whole subject and even the next lectures is just we are going to deal with this. This is the way that we are going to, this is the notation of the single variable. If it is indefinite, we have our integral f(x) dx. So you find that the whole function, the dependent variable is x, independent variable is y. So that is. Or if it is definite, then you have from a to b. Then you have f(x) dx. So this is single variable intervals. Either this or this one. Indefinite, finite. Integral symbol, integrand, variable of integration. Lower limit, upper limit. That is single variable intervals. Number 11, which is the last item knowledge for today. We have multivariable intervals. Say multivariable intervals. Okay? Because this is the last item knowledge now. You have to enjoy it. So the best key question is, what is multivariable? So multivariable interval. As I told you that this lecture has been prepared to have ordinary diploma students who are pursuing science, or who are pursuing engineering mathematics in science, or engineering mathematics in engineering, or even A-level students who are pursuing advanced, we say that pure mathematics. So remember that the whole subject, all the stories that we are going to, all the truths that we are going to discuss about single variable. Why am I introducing to you multivariable? Because I know if you keep on your academic from all level, from A level to undergraduate studies, you will find these multivariables in the second year, or even the first year. The second year, first year and second year, mostly second year, mostly first year. And also, if you are pursuing ordinary diploma or A level, I told you that in academics you will meet with this concept. So that's why I want to tell you in advance, because I've been teaching undergraduate students for 5 years right now, and one of the challenging concepts for them, they forgot, or they had bad teaching of all the concepts on the calculus: differentiation, integration, and differential equation. So instead of focusing on that advanced concept, I used to go backward and remind them how we differentiate, how we integrate, how we solve the differential equation, which actually is a tedious work, because that's not a part of mine, it's just a part of somebody who have been paid or have been delegated with that task. But because I like them to understand, and that's the main focus of these lectures. All my lectures, I like students to understand, I like them to enjoy, I like them to see the beauty of mathematics, or the beauty of engineering mathematics. So I have to take a course to go back, to remind them since that at the start. So that's why that now I say that I want to build the aims of these lectures. Means by that time, in the near future, if I'll be teaching those undergraduate students, they forgot this concept. We don't have enough time to cover everything. So I will ask them to go back to these lectures in order to watch. So dear viewer, please take this concept along. When you are going, even if you are going for postgraduate studies, you'll find calculus there in engineering. I tell you the truth. You'll find calculus, you'll find algebra, you'll find those modules, and specifically, especially for the times of whether it is PhD, you will need this concept, because actually engineering is applications of mathematical models. So we do modeling a lot in mathematics, in engineering. Even if that you don't see the real applications, but believe it that a lot of structures and a lot of systems that we have in the world have been developed by using the engineering or mathematical models. Okay? So we say that multivariable intervals, or interval, we say that is the interval is the integral. Okay, is the integral which we have in which and also in here in which you have common in which its integrand. Okay, it's integrand. We say that is integrants, which integrals are the integrals in which integrand is respect to only one variable, in which the integrations of the integral, in which the integration of integrand is done with respect to only one variable. Just let me just write it properly here. Say that is the integral in which its integrand is integrated, okay, with respect to more than one variable. More than one variable. What does it mean? So in this time we say that the integral or our integral, the integrand, is integrated with respect to more than one variable of integration. Variable of integration. What does it mean? How do we do notations of this? Okay? How do we do notation of this? This is the way that we do notation. Integral. Okay? So multivariable means that we say that for indefinite multivariable, we say that we have f of x. Let's say y, dx, dy. And also if it is triple integral or double integral with limits a, b, c, d. So the way that we find that we have f of x, y, dx, dy. So you find that now we have more than one variable for integration. Here we have more than one variable for integration. If it is triple, because I want to excel 2, then now we have three integrals. We have f of x, y, z. Then we have the arrangements is actual interesting. You can just change, depends on what you're focusing. If it is definite, then you have from A to B, from C to D, let's say from G to H, whatever. Then you have f of even x, y, z. Then you have dz, we have dy, we have dx. So these are the symbols of multivariable integrals. So I want now to suppose that this is Roman 1, this is Roman 2, this is Roman 3, and this is Roman 4. And this here, I want to do the homework, as I told you. Homework. So just write it. Homework. Homework for you. Okay? So what the question? Okay? So you say that here the question. Okay? Identify the following terminologies. A, or identify terminologies. Identify all the terminologies. Identify all the terminologies. Use the all terminologies of integration. Use the again, Roman 1 up to Roman 4. Okay, so we've covered almost how many terminologies? 11 terminologies. So just identify them if they are all the 11 terminologies or 10 means you have to say.